Magandang araw, ako si Kuya Code. Welcome back to my channel where I teach Python through fun and practical examples. Today we'll be diving into software design patterns. So in this example, I'm going to continue to theme my classes around games, but these concepts are definitely not unique to games or even Python. This is just what I'm going to be doing in these next several videos. So these design patterns, by the way, are based on a book that I read called Design Patterns, Elements of Reusable or Object-Oriented Software, aka the Gang of Four. Now on to the specifics of this video. So in a game, certain things should only exist once, like game managers, audio systems, or global settings managers. You don't want multiple instances of these running around causing weird issues. So that's where the singleton pattern comes from. It ensures that a class only has one instance and gives us a way to access it from anywhere in the code. So in this video, we'll break down how this works and we'll show the implementation of it. So right off the bat, I have my code here that I already have written. I'm just gonna go ahead and run it so you can see what happens. So basically, we have two instances of this game manager class, one with hello and one with world. And then when we print A is B, it basically says false because it's saying that these two objects are not the same. There's two separate instances of this object. So of course the whole point of a singleton class is that you don't have two instances or more instances of an object or a class. You only have a single one regardless of how many times you make a new object. So the goal is basically for this to return true even if we have more than one. So just a couple things. The self that we're passing in here is always just referring to this specific instances method or property. So obviously this hello text here has a property for the text. So each one has its own text and then self returns that specific object's text. But because we're not going to be having more than one instance, we don't really need self at all. There's actually another one called CLS, which refers to as class. But also, we don't need this method at all because even if we only have, or even if we have a singleton class and multiple references to that one instance, it's still going to call this multiple times. So we can basically just delete this. Actually, I won't delete it. I'll give it another name because we'll still want to initiate some shared variables. I'll just call it init game instead. I'm going to be deleting, we don't really need this text anymore. Don't need that. Don't need that. Get rid of this. And then, because we still need to initialize and create the object, we'll just use the built-in one here, which is new. And then we'll just pass CLS because we're not going to be using self. This can just be CLS, and in fact, all of these will just this one is actually going to be different because obviously we're going to have more than one player object. So this one would say itself, but for these ones, it'll just be CLS instead. So for this new constructor here, we're going to be first creating a instance variable. This is a static variable because every single reference to game manager will refer to this one instance. We'll just default it as none. And then whenever we make a new game manager object, we're going to first check if the class instance is none. And if that is the case, we're just going to make a new one, pass it up to the parent of game manager, which is the object class. It has a new method as well, CLS. And then we'll just call the init game method that we created. So underscore instance dot init underscore game. And then that's supposed to be none. So this covers this specific first case of A because this is the first one that we're creating. So obviously instance is going to be none. So of course it's going to go into here and it's going to make a new instance of the class. But then the second one, when you go in here, this is going to be false because this is no longer none. So it's just going to go to this, which we're just going to return cls dot instance. So we'll go ahead and do that. And then let's see what happens if we run this. I needed a dot here. Let's see. Where did I have my typo? Line 6. I missed a dot. Let me check. CLS dot is instance is none. CLS dot instance equals super new CLS, and then CLS dot or underscore instance equals new game. Return underscore. All right, so now everything works. And notice that it says true now, because even though we have two objects created, they're both the same instance. So that means if we change something in one, they're all changed. We're not just going to leave it at that, though. We're just going to add some extra methods in here just to kind of show how it works, or at least we're going to fill in these ones here. So for the init game, we'll just get some variables like cls dot, let's say, score equals 0 to default, cls dot level equals 1, and then cls dot players equals an empty array of players. And then we'll just print some text here, game manager initialized. So if we go ahead and run this, notice that it only gets initialized one time, even though we're calling it twice, because this method is only called once, which is right there, and it's So next we can add a player. So cls.players equals .append. We'll just get a new player object, which we're passing in here. We'll have to add it down there afterwards, and then we're going to print f player added to the game. And I could just put single quotes here. All right, and now for the increased score, cls.score plus equals points. And then I can probably just keep that passive, it doesn't really matter. And then for the level, this is like the stage, not an individual player level. So cls.level plus equals 1. And then we can just put some text here as well, like level complete. Now entering level, cls.level. All right, and then that's it for this class, and now we can do the player class. So of course, this is going to have multiple instances, so we'll just use the init. We'll have self, we'll just pass in a name, and then we'll just use the usual self.name equals name. And then for each player, they're going to have an instance of, or they're going to have a reference to the game manager, and then we can just do add player, and then just pass in the name. And then lastly, for defeat enemy, game manager dot increase score. And I mentioned this before, but because game manager is not a we're not going to have multiple separate instances, we don't need to use the we don't necessarily need to make an object like in this case, because all of these methods are unique to the class as a whole. So we can just do the class name dot and then just the method name. We don't necessarily need to reference a dot whatever like you would if you had multiple instances of the same class. And we don't really need this anymore. This is just for a we already kind of tested that this works, which we could even do it now. Make sure we don't have any issues yet. We don't have any issues and it still works. So we can go ahead and remove that. But now we need to make some player objects. So player1 equals player, just call it, I don't know, hero or something. And then player2 equals player warrior. So we got our players, and now player 1 dot defeat enemy. And then we'll just do the same thing for player 2. So player 1 is going to defeat an enemy, which is going to increase the score. And then player 2 is going to defeat an enemy, and that's also going to increase the score. But the idea is that the score should now be 20 because both of these players are referencing the same instance of the game manager class. And now we can just do game manager dot, we'll just do dot next level, and let's just see what the printout of that is. I put manger somewhere there, I think. So now hero is out of the game, war is out of the game, and this is referencing level 2 complete. So that's exactly what we were expecting. We'll also put in a printout for the score. I should probably go back and add that. And then where is the score? So here's the score. So we can just add in a print just to verify that this works. For the score increased by this number of points, and then total score cls.score. Now we do it again. So now the score was increased by 10 for a total of 10, and now the other player also increases the score by 10, and now we have a total of 20. So that's it for this video. If you found this video helpful, please like and subscribe for more coding challenges. Let me know in the comments if you have any questions or suggestions for future videos. See you next time on QCode. Paalam.